I'm going to do a quick lesson on points of concurrency, also known as our triangle centers. These were the notes that the students that were in Accelerated Coordinate Algebra had last year in their classes. So if you see, this is kind of a summary of all 4 triangle centers. The device that we use to help us remember where all of my children are bringing in peanut butter cookies, and this is just a way to help us remember what our triangle centers are and what they mean, how we form them. So if we take the first letter of all of these, we'll see at the end how that works for us. So the first one we're going to look at is the orthocenter. Now the orthocenter is formed by the altitudes, and an altitude of a triangle is just the height of a triangle, and that's the perpendicular segment that goes from one vertex of the triangle to the opposite side. And orthocenters can occur outside the triangle. I'm going to quick go to our GeoSketchpad and we'll take a look at an orthocenter real quick. So here I have a triangle, and what I've done is I have constructed, using GeoSketchpad, segments that pass through a vertex and are perpendicular to the opposite side. So we see these. I don't have the perpendiculars marked, but if I grabbed one of the edges, you will see how the orthocenter is the point where all those lines intersect, and it can be located inside the triangle, and if I move it, it could be outside the triangle, or if it's a right triangle, it's right on one of those vertices. So an orthocenter is interesting in the fact that it can be outside, inside, or on the triangle. So that's the orthocenter, and the orthocenter is formed by the altitudes, and altitude is just from one vertex perpendicular to the opposite side. Okay, the next one we're going to look at is the centroid. Now the centroid is the triangle center that is formed by the medians. Now median is just a segment that extends from one vertex of the triangle to the midpoint of the opposite side. So it's going to bisect that opposite side. Now the neat thing about a centroid is it's going to divide up where the centroid intersects the medians. It gives us a ratio, and that is formed because the distance from the vertex to the centroid is twice the distance from the centroid to the opposite side. So this is a 2x and this is an x. That distance from the vertex to the centroid is twice the distance from the centroid to the opposite side. So let's take a look at that on the GeoSketchpad. And so now we're doing centroid. So the centroid is formed by those midpoints. So this segment is equivalent to this one. This segment is equivalent to this one. This segment is equivalent to this one. It's going from the vertex to the midpoint of the other side. Now if we look at this, we notice that the centroid is always located inside the triangle. But can you see how these ratios, that 2 to 1, 2 to 1, 2 to 1, is staying the same no matter which one we're looking at. That 2 to 1 ratio stays the same. And the centroid is always located inside the triangle. Okay, the next one is formed by the angle bisectors, and that's called the incenter. Now an angle bisector is just a line that divides an angle into 2 congruent angles. And the neat thing about the incenter is it's equidistant to the sides of the triangle. So, and when we find the incenter, we could actually draw in a circle. And we see that it's equidistant to all the sides because this radius of the circle, obviously, a radius remains constant. So the incenter is equidistant to the sides of the triangle. So let's go back and take a look at our GeoSketchpad again. And I thought I had them all open. Let's minimize that one. Okay, let me come back in here and I'll close that one. So maybe I can see the rest of them. There they are. Okay, there's my incenter now. I guess as I was playing with that one. The incenter, there it is. Okay, angle bisectors. So this angle is congruent to that one. It's bisected. this angle here is congruent to that because this segment bisected it. And I constructed those using GeoSketchpad. And if we see the end center is also always located inside the triangle. Okay, please ignore that bell. When you are, once we've found the end center by constructing the angle bisectors, this is the end center, and the end center is also the center of a circle, and we can construct that circle by selecting that end center, which is the intersection of those angle bisectors, and doing a perpendicular line to a side, so we can construct a perpendicular line. So now we have this point of intersection between that perpendicular line and there we go. So to construct the circle, you would just go construct the center and pick that point that was on that perpendicular line, and we create the circle. So here you can see that no matter what happens, the circle is the center, and the center of the circle is the end center. So that radius is the same to every side of the triangle, no matter what I would make it look like. I can turn it into a nice little cute, I can turn it into an obtuse triangle, we could go with a right triangle, and that distance from the center to a side remains constant because it's the radius of the circle. Okay, hope this helped with end center. Next is circumcenter, and you'll notice we can construct the circle with that one also, but it's a different measurement. And take a look at our perpendicular bisectors, and our perpendicular bisectors form the circumcenter, so the intersection of those. That's just a segment that goes from the midpoint of a side that is perpendicular to the other side, and you'll notice that this one doesn't generally go through the vertices of the triangle. It's just the perpendicular bisector of a side. And the neat thing about this is it is equidistant from the triangle's vertices. So ignore that bell. If you're listening to this during the school day, that bell is not for you. So let's go back and we will look at the circumcenter. Here it is. And the circumcenter could be inside, outside, or on the triangle also. So let's see if I can create, let's see, center and point and construct the circle. There we go. And so we can see it's equidistant to all the vertices. Okay, so the pneumatic that we used was all of my children are bringing in peanut butter cookies. All is for altitude, and that gives us orthocenter. M is for median, and C gives us centroid. Angle bisectors are bringing, that's angle bisectors. N for end center. And then perpendicular bisectors, peanut butter, and circumcenter, cookies. And so that was our little mnemonic to help us remember that. Hope this helped, and if you have any other questions, please let me know.